This is the sun. It has been radiating light in our sky for billions of years. It's the only reason why we are even alive. But we have only been able to study it under the safety and comfort of our home. That is, until now. The sun. It is 864,000 miles across. At its core, temperatures can reach up to 27 million degrees Fahrenheit. The surface of the sun, known scientifically as a photosphere, is actually really cool, at only 10,000 degrees Fahrenheit. But its outer atmosphere, the corona, reaches temperatures of up to 3.5 million degrees. Imagine standing at a campfire and walking away from it, only for it to feel warmer. For almost 6 decades, scientists have been puzzled by it. For those long years, the technology needed to shield such a spacecraft from the heat of the sun was not developed yet. Not only that, but to launch a spacecraft closer to the sun would mean massive rounds of thrust. But those long years are over, and it is now a new millennium, full of new technology. And with that, a new mission was created, to create a probe with 3 main objectives. First, to trace the flow of energy that accelerates solar wind. Second, to study plasma and magnetic fields at a source of solar winds. And finally, to discover what accelerates and transports energetic particles. And this mission would soon create the Parker Solar Probe. Back in the mid-1950s, a young man by the name of Eugene Parker published his thesis on how stars, like our sun, radiate energy. He called this energy solar wind, and he described an entire system of plasma, magnetic fields, and energetic particles. He also published a theory on why the corona is so much hotter than the surface. He suggests there are many small solar explosions, called nanoflares, which would cause the corona to heat up. Parker received a bachelor's degree from Michigan State University before receiving a PhD from Caltech. He then taught at the University of Utah before moving on to the University of Chicago and the Fermi Institute. Parker would receive many awards, including the National Medal of Science, the George Ellery Hale Prize, the Bruce Medal, the Gold Medal of the Royal Astronomical Society, and many more. But his greatest achievement of all was seeing his own probe, named after him, launch into the great night sky. Rockets propel themselves by generating thrust through burning fuel. To launch a probe to such distances, such as the sun, would require an external force to propel the spacecraft even further. The Voyager 2 probe utilized the extreme masses and gravity of the larger gas giants to propel itself past Neptune. But to launch a spacecraft to the sun? At the time, scientists theorized about launching the probe toward Jupiter, and then using Jupiter's gravitational pull to give it a 180 and propel it towards the sun. But was this the most efficient way? Scientists stressed on this idea. It would be extremely expensive, if it was even possible. But then, a new idea came up, to use Venus. The mass of Venus is not even comparable to that of Jupiter, but it is much closer. By using more flybys, it could achieve the same effect, just much easier and much more cost-friendly. This would also be aided by the fact that it would be launched from one of the most powerful rockets to have ever been created, the Delta IV Heavy. The rocket exerts over 350 tons of force, and has a long history of lifting various satellites into orbit. But the Parker Solar Probe is not just a simple satellite, it is one of the greatest technological marvels of all time. Designing the probe would be the largest challenge. The probe needed to be mounted with instruments that are state-of-the-art to even be able to do research near the sun. The mission is not simply to reach the sun. In fact, the probe will complete 24 orbits around the sun over the span of 7 years. The equipment on the probe must be nothing less than the best. These instruments also must be kept at room temperature, and to do that next to the sun? To many, that seems like an impossible task. But with recent technological advances with carbon heat shields, they have designed a carbon composite shield, 4.5 inches in width, only weighing 73 kilograms, that would keep the interior at a regular 85 degrees Fahrenheit. Even though the temperature is extreme, think about it this way. Humans can easily handle the heat in a sauna, but if you transfer the same heat to a stovetop, we would no longer be able to do so. The corona is like a massive sauna, just millions of degrees hotter. The final design is a 680 kilogram probe, the size of a compact car. The probe was built and will be managed by the Johns Hopkins University Applied Physics Laboratory. The probe carries 4 main instruments: the Solar Wind's Electrons, Alpha, and Protons Investigation, or SWEEP, which counts the abundant particles in solar wind. This detects the speed, density, and temperature of electrons, protons, and helium at the corona of the Sun. This instrument was built by the Smithsonian Astrophysical Observatory in collaboration with UC Berkeley. The probe also carries the Wide Field Imager for Solar Probe Plus, which is a telescope used to see solar wind. The Electromagnetic Fields Investigation, known as FIELDS, measures the shockwaves in the Sun's plasma. And finally, the Integrated Science Investigation of the Sun, known as the ISOIS, takes inventory of elements in the solar atmosphere using a mass spectrometer to study the charged particles. Together is the vessel that will be sent 94 million miles to the Sun. And on August 12, 2018, at 3:31 a.m., it was launched at SLS Complex 37 at Cape Canaveral.
10, 9,
8, 7, 6, 5, 4, 3, 2, 1, 0. Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe, a daring mission to shed light on the mysteries of our closest star, the Sun.
3R68 look good in the full thrust mode.
On November 21st, 2021, it set the man-made object speed record, going 364,621 miles per hour. But at its closest approach, it is estimated that it could go faster than 430,000 miles per hour. It also shattered the distance record to the Sun, which would only be 3.83 million miles from the Sun, 7 times closer than the orbit of Mercury. But why? Why should we spend so much time and money to send a spacecraft to study the Sun? Why can't we just study it from Earth? Well, the Sun is the only star that we're actually able to study up close. Dr. Kelly Korrick describes this similar to receiving a postcard of vacation versus actually traveling to the destination. And until we study the Sun, we won't know how other stars in the universe might work. Another major reason is due to solar weather. Since solar winds shake up the Earth's magnetic field, many satellites are affected, and the solar wind may even change the orbit of such satellites and interfere with its electronics. Studying the solar wind may help us predict and protect future satellites from such solar weather. Solar wind is also found all across the solar system, so we need to study what it is before we can continue exploring further. The Parker Solar Probe, one of the most complex and insane vehicles designed by man, set to complete one of the most difficult missions ever. Only a decade ago, mankind would have found such a mission impossible. But as Parker continues its orbit on our Sun, we eagerly await for all future discoveries to be made and the endless possibilities that lie ahead.